So imagine a mere 10,000 years ago that there was an ice sheet here extending a little further south, but you can see the end moraine a little further south, furthest extent of the ice. But the ice, over 5,000 feet thick here, go further north towards the North Pole Arctic Circle, and the ice is getting thicker and thicker, so by the time you get to the Arctic Circle it might be 10,000 feet thick. So you get this tremendous weight pushing from the center out, causing the ice to slowly bulge and advance. And as it is, it's acting like a bulldozer to, bulldoze hills like this ridge that we're on, called a moraine, and obviously have a big impact on the landscape. So here we are 10,000 years later, which is essentially a blink of an eye geologically, and the terrain hasn't changed much.
With such a large mass that is only increasing in size, the glacier builds up a great amount of momentum with just the slightest bit of velocity it has from expanding. This momentum is very difficult to stop and has a significant effect on shaping the physical world. The laws of physics are always present on Earth and govern even the most minuscule events.
Moving at a speed of 1/100th of a millimeter per second would have roughly the same momentum as a space shuttle launching or all of the cars in LA traveling at freeway speed. This is because of the glacier's extremely high mass, which makes up for its extremely slow speed. On the other hand, the kinetic energy of the same glacier is only 50 joules, which is about the same as the amount of calories contained in a poppy seed, or the energy in a drop of gasoline too small to be seen without a microscope. This is because, despite the glacier's tremendous mass, its kinetic energy is a result of the square of its velocity, an even smaller value than the velocity itself.
Ice has bulldozed and carved the world we know on a colossal scale. But what is it that gives something as brittle as ice supremacy over the hardest and most resilient rocks to be found on the planet? To find out, you need to see inside a glacier. The Svartisen Glacier in Norway is one of the few places on Earth where ice can really be seen in action. It's thanks to this glacier that scientists are starting to understand the secrets of ice's great power. Deep beneath the glacier, in a chamber at the end, scientists come face to face with ice. Then it's 2 days of hard work using hot water to melt a cave big enough to get inside the glacier and see it in all its glory. Self. But the ice cave has another surprise.
Have you seen this?
It's an air bubble, is it?
It's not an air bubble. This is water.
Oh,
here.
Look at that!
So this is, we opened this up when we were melting, but before then it was totally enclosed in the ice.
These water pockets apparently make the ice less brittle, so it can bend around obstacles in the landscape. A glacier is not the solid mass that it first appears. Seeing it from the inside has given me a completely different perspective. It seems almost alive. As if to prove the point, the ice invades a space we've left behind. In just 3 days, our magical ice cave disappears.